Okay, great. So hi everyone. Um, my name is Bumi Akiremi, and I'm a Gold Microsoft Student Ambassador. And with me on the studio here is Sam Ayo Kende, right? He's a senior data scientist,
Yes.
AI engineer, and I'm a software engineer. Like, he's my big boss up there, right? He's an amazing guy, and I'm really so excited that he's here today to speak to us on designing AI solutions for sustainable development, opportunities and best practices, right? So I'm sure you should. He's a little smiling already because I'm excited for the session, right? Sam, I guess you want to like take over now. Right.
Okay, guys. Hi, everyone. So it's evening Nigerian time. So I just want to be sure that I'm very audible, right? Yeah. So my name is Sam Ayo, and briefly about me, I'm a senior data scientist and an AI engineer. I began my journey as a software engineer, and then over time, over the years, I grew into the data role, right? Data analysis, then data science, and then specializing in AI engineering. Um, I have a couple of backgrounds in cross-industry development that covers both IoT, media and advertising, energy, retail with customer segmentation, modeling and risk scoring, prediction, and the likes and the likes. But really, that's not what I'm here today, right? So today, I understand that you have begun a very unique challenge in building solutions that are around the SDGs, which are sustainable solutions, right? And the sustainable solutions basically are just 17 goals set aside by the UN to see how we can project the world globally for about 15 years, right? Which is 2050 to 2030, which is really amazing. And the beauty about all of this is technology will always have the role to play, and then AI will always have a role to play. And like I will always tell most people, the goal of artificial intelligence is not to take you from your role. The goal of artificial intelligence is not to make you obsolete. Technology is what makes roles obsolete, not artificial intelligence. Artificial intelligence is a tool, right, that augments the process, it augments your work, it makes your work easier and faster, just as we learned what machines are, right, in elementary school. Is a tool that makes your work easier and faster. So that's what basically artificial intelligence does for us. And basically for me, right, having a background in economics, that has just been my progression and my craze for artificial intelligence, right, and how these solutions are actually built. But the truth is, for everybody, it never begins with, oh, I want to do AI. It always begins with maybe a spark somewhere, maybe something you thought about, maybe you're just wondering, how do machines really work, right? Or maybe you're just saying, what is really behind the hood, right? In all these processes that runs, and then your curiosity just, it gets the best of you and you find yourself in this room, right? Or maybe for some of us, it is just to make money. Right? As most people, when you ask them, why are you doing this? They say, I want to make money. Or some would say it's my passion. Well, whatever the case may be for you, right? Artificial intelligence is designed to put that balance point and designing solutions that will actually scale, right, and fit right in the center of the sustainable development goals is what will actually be an enabler to uh, catapult the entire technology ecosystem to the next level. Okay, so I'm just going to move on with my slides. So just a very, very brief background about me, and some very certifications that I have that are relevant to what we're discussing here today, uh, and my also my experience both in field and off the field, right? I have always had a very strong inclination towards artificial intelligence for the longest of time as I can remember, right? And that has propelled me to look forward to some critical certifications that can really push me and position me at the edge where in where I can put this technology that is in demand into real practical use And that is really what has pushed me to exactly where I am today. All right. So what we'll be talking about basically, right? So we're going to run the presentation this way. Um, Whatever questions you have, please prepare them, keep them at the end of my slide. I will be most glad to take them, as many as I can and as much as the time can permit. So I'm also critically trying to manage my time, but I will create enough room to answer all your questions regarding designing, deploying machine learning solutions, and for sustainable development at scale. So we're going to be looking at four points in our agenda. We'll be looking at what is an overview about artificial intelligence and machine learning, and then we're also going to look at designing AI solutions. Right? What does it mean to design AI solutions? How can AI solutions really be designed? And then we're also going to look at how do we move from notebook to production, right? How do we move from writing scripts to creating customer relatable solutions that can render value both for businesses or for humanity, right? Because that's basically all it is, right? We want whatever you're building has to have value because that's what the people can really relate with. They cannot relate with wow, they cannot relate with oh my god, you're so intelligent. What they can really relate with is does it really give value, right? And to be very frank, that's really what pushed OpenAI's ChatGPT to the edge, right? And made it really, really blow up across the entire world, right? Then across the globe, right? The value that it's multidimensional with value, right? And when we see, oh, it gives a lot of value, can be applied to different scope. The value begins to be derived from such kind of AI solutions, and then boom, right? You see, it's now fused into almost any product that interacts with their API. So we're going to look at overview of what is artificial intelligence and machine learning. We're going to look at designing AI solutions. Then we're going to look at deploying these AI solutions to production. And then finally, we're going to look at what are the opportunities that exist in sustainable development. Um, you'll find the last point really, really interesting because for your hackathon that you're working on, right? So that your solutions are really, really tailored to artificial to sustainable development goals are really tied and are really solving one of the problems in the SDGs. Okay, so basically, when we talk about artificial intelligence, the first thing that comes to most people's mind is iRobots or apocalypse or AI is coming to take over the world or AI is going to take over the universe or AI will kill us one day or the end of the world is coming. I really don't blame people, right? Elon Musk, Jeff Bezos, right? They've given some reviews in the past that are really, really quite discouraging to the growth of AI. But notwithstanding, the growth of AI have been really, really geometric, right? Talk about the times of convolutional neural networks, generative adversary networks, stable diffusion, DALL-E, Chat GPT-3, now Chat GPT-4, right? So the growth has been massive because as more techniques are discovered, more use cases for those techniques begins to evolve, right? But really, 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 when we talk about artificial intelligence on a granular level, do you really think artificial intelligence is going to take over the world? Do you really think robots are going to come on and then take over the world and then kill all humanity and then take over our brains? All those stuff we see on sci-fi movies, right? But so I'm using this infographic to really depict what it actually looks like for most people, right? For most people, especially non-scientific folks, right? What they think about AI and what most AIs really are, or what they really do as at this particular point in time, right? You can see from the prediction of the model on the right, is predicting a fork as a dog, right? Um, Whereas people are actually on the craze that AI is really going to take over the world. Okay, so really, what is artificial intelligence, right? So when we talk about artificial intelligence, it's really, really dicey when you try to break down or cascade what really or unpack what really is artificial intelligence. And the problem really is that how can we fully define intelligence, right? The difficulty in trying to define fully what we would consider to be human intelligence poses a threat to the actual definition of what artificial intelligence really is. And of course, then we have the AI effect, right? And then we also have mix up between the different stages in the AI hierarchy and then the types. So when we talk about really human intelligence, right? How can we really define when we say a person is intelligent? How do we really define the intelligence? Is it by their score in school? Is it by their performance on a board, on a leader's board? Is it by how well they are at math? Is it by communication? How well they are at communication? How do we really define intelligence, right? And then the AI effects of the AI effect on people, right, is another limitation. And then we know we have different stages in the AI, right? We have different levels in AI, and then we have subsections of AI. So these interwoven limitations poses a really strong threat on what you might want to really say is artificial intelligence, right? And that's why majority of the time when they say AI is sentient, it becomes a debate on how would we really say AI is alive? Are we going to say AI is alive the moment it can speak? Are we going to say AI is alive the moment it can feel? Are we going to say AI is alive the moment it can see? Because if we're going to go by those parameters, then computer vision is AI is alive. Natural language processing is AI is alive. Audio analytics is AI is alive, right? So that those limitations, but if we're really going to simply put what AI is, right, we can safely say it is a branch of science studies, right, dealing with the simulation of intelligent behaviors in computers. It's really just studying how computers become intelligent agents, right? How they can effectively uh, take up tasks that are complex and break them down into granular tasks and then execute those tasks, right? So basically, we can just put AI in that level. But then on a bigger, larger scale, right? AI is basically just designing computer solutions that can mimic exactly how the brain cognitively processes or handle tasks on different levels. Okay, so basically we have seven, but just we're going to unpack those seven, right? Or rather, we are going to categorize those seven stages in artificial intelligence into three main levels, right? In artificial intelligence, and we're going to rank them based on AI wave, domain, and brain power, right? So when we talk about AI wave, we talk about artificial narrow intelligence, which is ANI, artificial general intelligence, and artificial super intelligence. So when we see artificial narrow intelligence, we talk about simple domain-specific tasks like image recognition, excuse me, like image recognition, text to speech, right? Uh, um, simple regression task, pricing models, right? Risk analysis models, just very domain specific problems that AI solve, right? Very domain specific problems, right? And basically, what those the capacity of those artificial intelligence solutions actually are, they are actually very limited. They do not match the human brain power at all, but they can be ranked close to a mouse's brain power, right? So that's we categorize those kind of AI solutions as artificial narrow intelligence. And then we have artificial general intelligence, right? They are cross domain, they have cross domain capabilities, which means they are AI that can be applied into any area, right? You can use the same AI solution for computer vision, for uh, audio analytics, for text analysis, for different solutions. So I put numerical data science, right? The artificial general intelligence applies and fits those areas, and they surpass human brain power, right? Collectively, they surpass human brain power. And then we have artificial super intelligence, which means it has cross domain capabilities and it applies to virtually every single area, right? It is a super computer and it surpasses human brain power, right? And provides us the fusion, okay, that allows AI to collectively and cognitively work alongside with humans, right, in the long term. Okay, so these form the three major types of artificial intelligence, or levels or stages, right? Better put as stages, the three main stages in artificial intelligence, right? Now, the debate of whether we are in AGI, right, it's still very, very unclear, because solutions that claim to do what are AGI capable often fail in the very, very short term, right? Artificial superintelligence is still mystical and mythical, right? It is still mystical and mythical, and it's high end in the future, right? But what we are currently executing now, right, across the AI domain is artificial narrow intelligence. We just simply implement intelligence agents to carry out domain specific tasks and solve domain specific problems, whether complex or simple problems. Okay, I'm just going to try to really stay on top of my time. So now let's talk about machine learning, right? When we talk about machine learning, as you may have already know, is a subset of artificial intelligence, right? That gives machines the capability, right, and um, uh, the cognitive approach to be able to learn from previous data and improve upon those previous data to provide prediction on futuristic data, right? So what machine learning really does in a nutshell is look into historic data, look for existing patterns, use those existing patterns to map out relationships, and use those relationships to predict futuristic patterns for unseen data. Nothing really out of the blues happening inside at machine learning beyond just already existing patterns that are mapped and used, right, to unlock or provide insight on future unseen data. And the goal of machine learning generally, right, is just simply to develop methods that can automatically detect patterns, uncover those patterns for prediction in the future, and or basically for outcomes that are specific interest of domains expert and domain knowledge bases. Okay, so when we talk about the types of machine learning, we have supervised learning, unsupervised learning, and semi-supervised learning. But semi-supervised learning will really not be the case study, because it's the majority of the time sitting in between supervised and unsupervised, and always inclining to unsupervised the majority of the time. So we're just going to focus on the two main industrial approaches, which is supervised learning and unsupervised learning. And when we talk about supervised learning, it means building AI solution based on historical data, right, that have a given set of input that is mapped to a given set of outputs, right, and having the algorithm understand or interpret the relationship between the input data, right, and the labeled output data to provide recommendation or to provide prediction for future unseen data, right? So it's just the supervised learning is really just around mapping the relationship between unseen data and already mapped seen data, right? It's physical terms you find in supervised learning are featured set or pre or X, right? You can call the feature set of the X or the independent variable, right? And then you have the Y, right, which is also called target or the label, and it's the dependent variable, right? So you have the X and the Y, or the feature sets and the feature sets and the target, or the feature set and the train. You have those two basically, right? A good example of supervised learning cuts across linear regression, classification trees, and some very, very small and light numerical neural networks. As supervised learning algorithms, right, as I mentioned earlier, can allow you understand patterns in unseen data, but one disadvantage with them is it relies strongly on already labeled data by either data experts or uh, data engineers, right? Already labeled data. And then we have unsupervised learning, right, that focuses more on labeled data, right? Instead, what it does is it learns the patterns, right? It learns the pattern within the data and uses the pattern within the data to infer upon the same data itself using either clustering means, right, or uh, either clustering means or aggregation means. So when you look at supervised learning, it's basically for problems like customer segmentation, color classification, right? When I say color classification, it's not color classification with the label set, right? Now it's color classification within the 3 times 3 pixel matrix. But that's really out of scope right now. So I'm just going to focus on more of numerical examples, numerical data examples to explain unsupervised learning, right? So it's focused majorly on uh, allowing models or machine learning to work, right? To work and discover patterns on their own, right? And these patterns are usually undetected at first, right? And the output data, which is the Y, are usually unlabeled. Another example of where you have unsupervised learning basically is in spam detection, right? Where you have your emails come in and then the algorithm or the model will have to label it if it is spam or if it is not spam, right? Okay, so I'm just going to move on quickly, right? So when we talk about machine learning at large, right, we can further break it down into under supervised learning, right? We can break it into classification and regression. Then in regression, we can have linear regression, a simple linear regression, multiple linear regression, polynomial linear regression. Sorry, polynomial regression rather, not polynomial linear, right? And then under classification, we can have binary classification, we can have multi-level classification, we can have multi-class uh, classification as well. And then under unsupervised, we can have dimensionality reduction, and we can also have clustering. And then further, we now have cross reinforcement learning, which focuses on an agent and reward technique to further expand the approach to machine learning. Okay, so let's move on and let's talk about designing AI solutions, right? Let's talk about designing AI solutions. So when we talk about designing AI solution, it's basically talking about workflows, right? How do I design or create a workflow that would kick off my machine learning solution? So basically, I have this very brief list, right? I call it very brief because the time is going to take me to really unpack this full list right now is what I'm trying to critically measure. Okay, so this is a very, very simple yet expansive design workflow for machine learning problems, right? A simple design workflow for machine learning problems. So you've identified the problem you want to solve, right, in the SDGs, and then you want to design an AI solution that is going to solve that problem, right? So basically, how do you start? You start first by defining a workflow. Your workflow is going to cover your end-to-end process from how do I start to how am I ready to say I'm done or this solution is completed. And basically, how does it really begin? In stakeholder engagement, right? In the speaking event I had yesterday, I took a lot of time to talk about decision makers and stakeholders engagement in the data space, right? So when we talk about understanding the business flow, it's really having lots of stakeholder engagement. It's that particular stage in your design workflow that you need to understand and say, hey, who are the critical players in this particular solution I want to solve? So let's take a classical example. You are trying to build a loan prediction application, right, using machine learning. And you want to start out by saying, how do I really understand the problem? This insurance organization want to effectively and efficiently disburse loan. They want to make sure that whatever loan that they're disbursing, right, they are not disbursing loan to people, right, that would in the long run default. How do I effectively design this? So the first thing you want to do is create engagement with the stakeholders. The stakeholders could be the line manager, it could be the head of department, it could be the officer in charge of loans, it could be the customer relations manager, right? You need to interact with the stakeholders, right? And it could also be the customer. You can also throw out a survey to really understand the customers. So you start first by building that understanding of the problem with engagement with the stakeholders. And then next, you create an engagement with the decision makers, which are usually the C-suite, right? The C-suite individuals, the CEO, the CTO, the COO, and sometimes the CFO, right? And ask them critical questions about the solution you want to solve. For example, you want to start by saying, how do we ascertain if a person gets a loan or not? What threshold do we consider a person disqualified to get a loan? What parameters do we use for judging if a person will default or if a person will not default? right? You need to ensure you understand this critically well so that you design a solution that is actually of value to the domain and does not defy the ethics within the domain, right? Because it's very, very important that whatever you're designing follows the strict principles in the domain, or else you find out that you may have designed a solution, but there are a lot of bias that has been introduced through your understanding of the business problem itself. And then the next thing you want to look at now is your data collection. How do I get data? Where do I collect data? Sometimes, right, it can be crazy. You may be in a team where nobody collected your data for you. You have to go and get your data yourself, right? In that scenario, you ask yourself, what are the right sources of data, right? Would I do systemic data collection, or would I go ahead and get data from already existing sources, right? So, and then if I get them, what is the quality of the data, right? The quality of the data goes a very long way. You need to think about data quality, right? And how specific is the data to the field, right? So once you have your data, the next thing you want to do is you want to ensure that you now store your data, right? So basically, a basic storage mechanism for data at this very maiden stage might just be a basic Excel spreadsheet, a CSV file, right? Or could be as maybe as elaborate, right? Depending on the use case, as a simple Postgres database or a MySQL database, right? And then the next thing you want to now look at is deep diving into the data understanding. The data understanding is basically going to cover some very in-depth descriptive statistics of what your data is actually saying, right? You need to really understand what does the data say, what does the data mean, right? And then you need to also do some very, very crazy uh, 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 aggregation, right? Some very crazy overview of what does the data really say, right? What are the columns mean? What kind of data types are in the columns, right? How do they? What kind of distribution is my data? You really need to take some time out, right, to really look deeply on what does this data really say, right? So that you ensure that whatever you're building, you have a clear head on of the type of what the data is saying and how that data will really matter in the long run when you get to your model training and model selection. Okay, now when you're done with that, the next thing you want to now look at now is your data cleaning, right? How do I clean my data? Now, cleaning your data is a very, very reiterative, right, and a cyclical process, and it is domain specific. I'm not really going to go deep dive into data cleaning. Like I said, I'm really managing my time, and it's really not doing me justice. But data cleaning, right, is domain specific. You need to put that at the back of your mind. So when you're cleaning your data, you need to carry the stakeholders along so that you don't, in the course of cleaning what you think should not exist, you end up taking away important features that are key parameters in the deciding factor in your model function. You really want to put that in mind. You cannot clean your data without constant engagement with the stakeholders, right? And there are a lot of there are plethora techniques for cleaning your data, from imputations to using central tendency measures, right? To imputations, and even using machine learning, right, to clean your data. So there are a lot of ways and techniques for cleaning your data. And then the next would now be your experimental data analysis, where you draw visualizations to really understand how your data really looks like, distributions, right? Answer some very basic questions that will further buttress how your model is going to be built, right? For a data analyst, it's largely going to stop here, but for you as a machine learning and AI engineer, be looking at building a solution that's going to scale. You're not ending here, right? Once you're done with your experimental data analysis, you're now going to feature selection, engineering, or augmentation, right? Where you use different techniques like backward elimination, recursive feature selection, recursive feature elimination, rather, using decision trees, right, to rank up feature importance, to really, 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 really look at how what features are really important and what features really matters to your model. And then the next will now be your model training, where you have found an appropriate model for for a particular problem you want to solve, right? And then when you're done with training your model, you go ahead and evaluate your model. And when you see that you've achieved the baseline, you can now begin hyperparameter tuning, right? Tuning the data, right? Clean the data, then move on to model tuning, and then go ahead and tune the model as well, right? To find out different parameters that would really work, right, for your problems based on the evaluation method you have set for that particular problem. Okay, moving on real quick. Time is now so much against me. Yeah, so the next we are looking at now is model versus algorithm. So I'm just going to use this quickly and briefly to do clarity, to provide clarity on what is a model and what is an algorithm, right? Because most times you hear people saying things like, "Oh, I'm going to use a model to train my machine learning algorithm." Okay, so really, what is a model and what is an algorithm, right? So basically, a model is what you get, right? When you've selecting an algorithm, say random forest, ADA boost, XGBoost, Light GBM, a neural network, right? A model is what you get when your algorithm that you've selected has trained repeatedly over your data and is ready to be used to make prediction. So when you're differentiating both of them, ensure you understand that the algorithm is what you have, right, before you train on the data, and the model is what you have after you have trained on the data, because the model is just a set of function that you have arrived at, that when it's supplied an input, it gives a specific type of value as an output. Okay, so I'm just also going to move on real quick. Okay, so I'm just using this to further buttress right on the different models that algorithms rather that exist in machine learning. Right, when you talk about clustering, creating a problem, solving a problem rather in clustering, you have k-means, you have mean shifts, you have k-means. When you talk about supervised learning in basic regression, whether simple or multiple, you have decision trees, you have linear regression. When it comes to supervised learning and classification, you have a host, right? You have random forest, you have naive Bayes, you have SVM, you have XGBoost, you have Light GBM, you have KDNS label, and the likes as it goes. And then, yeah, so this is a very nice cheat sheet, right? A very nice cheat sheet that can help you determine what algorithm is perfect for a problem you're trying to solve, right? So you've understood what your data is. You want to pick an algorithm for that particular problem. What algorithm works best, right? So this is a perfect cheat sheet that can help you look at which is which, what is what, right? Which would work best and what would not work best. But the rule of thumb is if you're working a numerical problem, right, before you jump in and bring in the big guns, always try to use random forest, right? Always does the trick, easy peasy, before you jump in with big guns and big algorithms. Random forest is just a very good baseline to begin. Yeah, so now let's talk briefly about deploying machine learning solutions, right? So what are the different types of model deployments? I'm just going to focus on these three and talk about them briefly so that I can move quickly, right? So when we talk about types of deployment, we have batch processing where the data is already the prediction is already had before the customer requests for it, right? And then it's stored in the database. And then when the customer requires such service, the prediction is put from the database and it's rendered. A good example of that is your Netflix, right? Netflix uses batch processing to suggest movies for you to watch. Amazon uses batch processing to suggest products for you as well. Another good example, okay, so another type is stream processing, where it comes in real time, right? Where the model prediction comes in real time. Uh, a good example of that is computer vision and CCTV cameras. And then we also have edge deployments where the deployment is on the device, right? Where the deployment is actually loaded on the device. Some of those techniques exist in microcontrollers where they used to deploy ML solutions on field devices. Okay, quickly moving forward, it will be injustice to talk about deploying machine learning models without talking about ML ops, right? And what really is ML ops? So ML ops is just I'm done with building my model. I want to put my model as an application, and I want it to be supplied. I want it to supply predictions to users, right? When I'm done with my solution. So how do I take my script, my Jupyter notebook? How do I take my Jupyter notebook and how do I put it on the cloud for people to work with? right, as a solution. MLOps aims to assist iteratively in the deployment and maintenance of machine learning models in production so that it ends up as a reliable and efficient model serving solution for customers, right? And the goal basically is to reduce technical friction, right, to get the model from an ideation stage into a production level in the shortest time, reducing possible risk. It is so amazing, right? The solutions that MLOps techniques have provided, judging from the amount of ML solutions that are actually there in the Google and Meta junkyard, right? MLOps provide a very good and intuitive way for it to be done. So basically, right, what MLOps also provides is basic and great solutions in shared collaboration, ease of deployment, good version control monitoring, and retraining mechanisms that allow models to easily be trained. And a good way we can actually take advantage of this, right, is utilizing some of the amazing tools that are present in the tool stack, right? A great example is utilizing Azure AI, right? Using GitHub and also using the Power Platform tools. And that's what we're just going to look at really briefly as I prepare to round up my presentation. So really, when we talk about Azure, right, and Azure machine learning, what are we really talking about? So Azure provides us and everyone rather a very clear, flexible platform that supports and sustainably delivers and provides AI and ML capabilities for scalable solutions. And Azure machine learning really focuses on streamline that perspective, right, with a set of cloud tools that enables you to prepare data models, right, prepare your data as well, and then build your models in the cloud, train them in the cloud, and also serve them in the cloud, right? And it's super amazing. So basically, what Microsoft have really enjoyed over the past is an amazing breakthrough of success that covers both vision, covers both speech, and covers both language definition. And so basically, when we talk about utilizing these tools, right, like through Microsoft to provide continuous serving of your model, it's actually just a stage-by-stage iteration process that begins with your data, right? Either your data is in the CSV file, the log file, or from IoT sensors, right? Is stored into an Azure warehouse, right, or an Azure storage, or an Azure DB, right? And then from then on, you can now transfer it, right? If it's big data, you can use amazing tools like hard HD Insights, right? Hadoop Insights to iteratively work with the data. But if it's really lean data, you can just work with simple tools, right, in Azure. And then when your data is processed, you can then move them into model training, right, using Azure ML Studio, right, or Azure ML services to really create that iterative solution for you all in the cloud, right? And then after you're done with that, you can then, depending on the technique you're following, right? If you're following batch processing, if you're following processing, right, you can then go ahead and define exactly where you want the model to work with, right? If you're working with batch processing, you know you're sending it back into the database to call it in your app. If you're working with stream processing, then you're either supplying it as an event-driven microservice through or through APIs, right? RPC APIs that are scalable to ensure that it is served. Or if it's going to be on the edge, once you've done training, you save it in Azure Container Registry, and then from Azure Container Registry, you can call it through your Docker containers. Okay, so basically, what was an experiment basically, right, in Azure ML? What does it basically look like? Right, basically, it's just you preparing your data, as I mentioned earlier. Prepare your data, and when you're done preparing your data, you move the data into your work tool, right? VS Code or Anaconda, Jupyter notebook, right? You start from there, and when you're done experimenting, cleaning the data, processing the data, training the data, evaluating the data, tuning the data, then you're not sure you have your model. You can then move your model into a registry and then deploy your model using the web server, right? Majority of the time, most deployments, if they are stream deployments, are done using Azure Web App, right? Or you can use AKS, which is Azure Kubernetes Service, to deploy them, depending on the particular use case you're going to use to deploy this model, right? It depends on the deployment technique that you're really exercising. Okay, so I'm just going to move quickly, right, to talk about GitHub, how GitHub can help you empower your work as you also flow, right? So GitHub provides a version control that ensures machine learning solutions are reproducible, right? So which means that your machine learning solution in your GitHub repository, you can use version control to ensure that they are tracked, right, and they are well stored, and they are reusable across different projects or across different teams. And another amazing thing you can do with GitHub right now is work with GitHub CI/CD, right? So CI/CD is basically continuous integration and continuous development or deployment, or can be both. So we can say continuous integration, continuous deployment, continuous integration, continuous development, continuous integration, continuous deployment, and development, right? Provide, and it allows you to work with an amazing pipeline that provides you with a step-by-step guide on how you can create new versions of your notebook, right? New version of your software as you productionize them, new version of them, and can effectively track them, especially when you work with when you're linking them with Azure, which you're going to look at briefly, right? And it also introduces an amazing automation technique that improves the application deployment, right? Particularly if you're moving from integration, testing, delivery, and finally deployment. So it allows you to easily integrate, right, and move through these phases with ease. So this is a very simple workflow file of how GitHub CI/CD looks like. So if you're using GitHub CI/CD to deploy a Python web app, basically your workflow is going to look like this. You define jobs, right? A basic job would contain test, build, and deploy, right? And in that workflow file, you specify your environment variable, you specify all that the environment variables is going to install from your requirements, the txt file, and then you go ahead and build it, right? You build it on GitHub Actions, and when you're done building on GitHub Actions, you now define the workflow, which will automatically productionize it on an Azure web app. All right, so let's look at opportunities that exist in sustainable development. So when we talk about sustainable development, what opportunities really exist for you building an AI solution? We've talked about how AI solutions are built. We've talked about workflows in AI solutions. We've talked about deploying AI solutions, different techniques you can look at, tools you can also explore on Azure. Now, what opportunities actually exist in sustainable development goals? So, as I mentioned earlier, right, and you're well aware, we have 17 SDG goals, right, that cut across no poverty, zero hunger, recent work environment and economic growth, down to partnership for the goals, right? So 17 of them. So how can AI easily fuse into this and render value, right, or solve any of these problems? There are amazing ways that this can be done, but I have highlighted two and supplied some very critical examples of how you can tap into these solutions to build AI solutions. You can look at water and energy, right? Water, that should be SDG 3. Yeah, sorry, that's SDG 6 rather. And then energy, that's SDG 7, right? So we're looking at 6 and 7. So when we talk about water, what really can AI do to provide sustainable solutions in what that tackles problems that affect water? We can look at predictive maintenance of water infrastructure, right? Where you can build AI models that can predict faults in water pipelines, that can predict faults in water distribution facilities, right? That can predict faults in dams and water reservoirs, right? You can build AI solutions that can effectively maintain those infrastructures so that water is readily available for everyone and as at when they need them. Excuse me. The monitoring and predicting water demand, right? This particular solution is really amazing because last year I got to work on a solution exactly for this somewhere for northern Nigeria, where we had to build a solution, right, that would effectively monitor water and also predict and provide water in demand, right? So that water is always available, right, in demand, and water is monitored to avoid wastage. across buildings and across apartments, right? You can also look at monitoring wastewater resources, right? Ensuring that as water is dredged out of a particular canal or a particular housing region, it is properly dredged out to avoid blockage and flooding. And then for SDG 7, you can look at smart monitoring and management of energy consumption, right? How can you effectively ensure that people don't leave their bulbs on when they leave their house? Can you build a mobile application that automatically predicts the amount of power that people consume when they leave their energy on when they don't need them, right? Can you also create a predictive solution that can predict the amount of power a device will consume if it is left on, so that people can effectively monitor how they consume and how they use power and what devices they will need and the power that they can estimate they will be paying for. So those are amazing things AI can do with energy. Also, energy supply and in demand, right? You can make predictions for energy supply. Can we predict that a particular location, take for example Cairo, can we predict the energy, amount of energy that we consumed in Cairo in 2 years so that we can adequately prepare for that, right? So those are amazing things that AI can do when it comes to problem solving. And when it comes to situations like this, there's really no telling, right? Because there's really no end to the capabilities of AI can do, what AI can do, right? Because the human mind is limitless and the capacities is boundless. And it is those capacities that actually give birth to what AI can do. And as you innovate and as you build across different solutions and industries, you find out that as you continue to iterate and build it, although building is an iterative process when it comes to artificial intelligence, you get better and better and better the more you put it into practice and the more you effectively demonstrate this. All right. So thank you so much, guys. I think I will draw my curtain here. Hello, Bumi. Can you hear me? Hello. Okay, I don't think Bumi can still hear me.
I can.
Okay. All right.
Can
Great.
you hear me?
Great. Great. Yes, I can hear you. I can hear you now. I can.
Yeah. So thank you so much. Yeah. Thank you so much for the session. I'm sure like everyone that listened in like gained stuff. Even even myself
Okay. I think your network is a bit shaky. Um, Bumi, if you can hear me, I think your network is a bit shaky. Well, if you can hear me, I think your network is
think
not
this
doing
ML of
justice.
it.
Okay, I think I lost it for a couple of sessions
The
there.
hotspot.
Don't know if it's my network or if I really lost you, but
Think
I'm not sure.
just I lost in your way. You're still there and
Okay, I think Bumi is having some network difficulty.